So today we are presenting elevator control system, presented by Muhammad FIRDAUS, Muhammad HAFIZ HAKIMI, Muhammad HAFIZ, and Muhammad AMIR SHAH. So what is an elevator control system? An elevator control system is a set of components and algorithms that manage the operation and movement of an elevator. The system ensures safe, efficient, and user-friendly transportation between different floors in the building, first come, first serve operation, where the elevator responds to calls sequentially. What is a priority queue? The priority queue class in Java is part of the Java util package. It is known that the queue follows the FIFO, first in, first out algorithm, but the elements of the queue are needed to be processed according to the priority. That's when the priority queue comes into play. Elevator control system using priority queue. An elevator control system using a priority queue efficiently manages floor requests by prioritizing them based on importance such as direction, proximity, or urgency. It ensures the elevator serves high priority requests first, reducing wait times, improving energy efficiency, and enhancing user experience. Why are we using priority queue in our system? First of all, for efficient request handling. A priority queue ensures that most important or logical requests, e.g., closest floor or same direction, are served first, reducing unnecessary stops. Next is for reduced waiting time. By prioritizing requests intelligently, passengers experience shorter wait times and faster service. Next is for energy efficiency. Grouping and prioritizing requests minimize elevator movement, saving energy and reducing wear and tear. Next up is our system demonstration. Followed by the explanation of code.
Okay, for me, it was my leaf class. So this is the main method, is the entry point of the application. It initializes the elevator and handle user input. And for this line, it creates a buffer reader object that read input from the console. It wraps an input stream reader which convert byte stream to character stream, allowing for efficient reading of text input. So for this infinite loop allows the program to continuously interact with user collecting their request. The program prompts the user to enter the number of users who will request the elevator. It reads the input and converts it from a string to an integer. Also, this loop iterates over the number of users. For each user, it prompts them to enter their desired floor and add that request to the floor elevator queue using the add floor method. This for a new thread is created to handle the processing of elevator requests. The request processor class implement the runnable interface, allowing it to run in a separate thread. This enables the elevator to process requests concurrently while still accepting new user input. For this loop checks if the elevator is idle. If it is, the program prompts the user to see if there are any new requests. If the user indicates there is a new request, it's prompt for the new floor and adds it to the elevator queue. If there are no new requests, the program print an exit message and terminate. So for next, we will We'll have Hafiz Rahim to explain elevator class.
This is the code for the elevator class. Okay, for the private static elevator, declares a static variable that holds the single instance of the elevator class. It is initialized to null and will be created when needed. Private queue initializes a private priority queue to store flow requests. The queue is implemented as a min heap, which allows the elevator to process requests in ascending order. Private in current floor is a variable that keeps track of the elevator's current position initialized to 1. Private boolean moving up is a variable that indicates whether the elevator is currently moving up or down. It is set based on the requested floor. The constructor is private to prevent instantiation from outside the class. This is a key part of the singleton pattern. Okay, this static method checks if the singleton instance exists. If not, it creates a new instance, it then returns the existing instance. This set flow method adds a new flow request to the queue and is synchronized to ensure thread safety when multiple threads access the request queue. The notify call wakes up any waiting threads that may be waiting for requests to be added. This add flow method also retrieves the next flow request from the queue. If the queue is empty, it returns null. The method is synchronized to ensure that only one thread can access the queue at a time. This get current flow method returns the current flow of the elevator, allowing other components to know its position. This set current flow method sets the current flow of the elevator and simulates its movement. It checks the direction of movement and updates the current flow variable accordingly. The method includes a loop that simulates the elevator moving to the requested floor, printing the current flow of each steps and pausing for a second to present the time taken to move. For this method, it checks if the elevator is idle by determining if the request queue is empty. It is synchronized to ensure thread safety. Okay, for this private wait for user input method, waits for user input after the elevator arrives at the floor. It prompts the user to see if there are any new requests, and if so, reads the new floor and adds it to the request queue.
Okay, for the last class, we have the request processor class. And then for this request processor class, this one actually implement the runnable interface that allow instance of request processor to be executed by a thread. Then we have the run method. It's the entry point for the thread when it started. This method contains the logic that will be executed in the separated thread. We have the elevator instance line. Actually, this line retrieves the singulated instance of the elevator class. This to ensure that the request processor interact with the same elevator instance that is being used in the MyLift class. Then we have the loop. This loop allows the request processor to continuously check for new flow requests. It will run indefinitely, processing requests as they come in. Then we have the get next flow request line. This line called the next flow method of the elevator class to retrieve the next flow request from the queue. If the queue is empty, this method will return null. Then we have the valid request conditional check. Actually, this to check the retrieval flow request is not null. If it's not null, it means there are valid requests to process. We have the verify request. This line is called the set current floor method of the elevator class to move the elevator to the requested floor. Actually, this method handles the logic for simulating the elevator movement and updating its current position. A reverse summary here. So, elevator control system using a priority queue efficiently manage the elevator operation by prioritizing requests based on their preferred criteria such as duration, proximity, and urgency. For the concept is a priority queue organized for requests with higher priority being your service first. And then the requests are sorted by factors like the current direction of travel and proximity to the requested flow. So how actually this work? It works by request button such address are added to the priority queue. Each request is assigned a priority. We have the proximity. We have closer flow to the elevator current position. We have direction, request in the current table direction and prioritizer. And the controller process request in priority order. So in conclusion, a priority queue in an elevator control system significantly enhance its efficiency and effectiveness by prioritizing flow requests based on the factors such as direction, proximity, or urgency. The system optimizes the sequence of stop, receive wait times, and energy consumption. This intelligent management approach not only improve the overall user experience, but also ensure a smoother and more reliable operation, making it an ideal solution for modern buildings with high traffic demands. And here's our reference. Okay, that's all from me. Thank you.